Started. Welcome everyone welcome to the mining seminar. Thank you all for coming. Today is going to be the mining department graduate presentation seminar. The idea for this is to get practice talking about our research in quick and efficient ways, and using a single slide is a good way to do that. Each person has 2 minutes. The current list of students is up. If someone's not here, we'll skip them. We'll give them a second just to make sure they're not here. And then the list is slightly different from what Fatih sent out, so I'll send another copy of this out later. I will be going first just as a demo, but without further ado, I'll get started. If you're not speaking, please mute yourself. And then when you're done presenting, also remember to mute yourself. Thanks. See if I can, there we go. Hello, everyone. For those of you that don't know me, my name is Joseph Troba. My thesis is on the recovery of critical elements from copper smelter flue dusts. I'm funded by the Critical Materials Institute as well as Rio Tinto Kennecott. The goal for my project is to evaluate flow sheets and develop one that can recover indium as well as cadmium from flash furnace ESP dusts, the smelter dusts. One of the challenges with my work is indium and cadmium are both critical for their use in semiconductors, particularly thin films. Indium only exists in low concentrations in the crust, and similar to cadmium is mostly recovered as a byproduct of zinc. This work focuses on the recovery of indium from flash furnace ESP dusts, and then the added benefit is that cadmium can also be recovered. My methods are primarily hydrometallurgical. I'm leaching and then selectively purifying many of the elements present in the dust. I'm also using MetSim process modeling software, and the inputs are based on experimental results, thermodynamic data, as well as literature values. This enables me to evaluate a lot of different options while limiting the total number of tests required. Thank you. Next, we'll proceed to, see, my screen covers it up. Patrick, you're up.
Yeah. Hey everyone, I'm Patrick. My research is about system safety for mine fire risk assessment of lithium-ion batteries. This project is funded by NIOSH. My advisor is Dr. Jürgen Brun. Lithium battery technologies like battery electric vehicles have some major benefits. EVs, they produce less emissions, create less heat, and reduce also electric power costs for ventilation. But they also have some potential hazards. Battery abuse can lead to off-gassing of toxic and flammable gases, to thermal runaway, and to combustion. And especially an underground mine creates a unique environment with a lot of hazards for with confined space and limited escape routes, roof falls, collisions with walls and other vehicles, mine fires from other sources, gassy and hot mines, and toxic and flammable gases from lithium batteries can contaminate the mine environment. And especially important is the limitation of the regulations and safety standards for PEVs in the mining. Understanding these risks needs new approaches, and the proposed research will analyze lithium-ion battery fires using the system theoretic process analysis, which is a new technique for analyzing hazards in complex socio-technical systems. It will allow the detection of problems in the overall fire safety control structure. Based on the method, risk assessment and mitigation strategies related to the lithium-ion battery fires will be then established. Thank you.
Hello everyone, this is Ebu Bekir and team.
This is Lithium.
Yeah, we work in the geothermal anomaly detection from hyperspectral images via deep learning project together. The project sponsor is Department of Energy, and we work. Actually, this is the phase 2 of the project, and in phase 2 we work in COSO geothermal sites. And our main approach is to integrate remote sensing, machine learning, and artificial intelligence to protect whether it is geothermal site or not geothermal sites, to use minerals, land surface temperatures, faults, or displacements, etc. I think Tin gives some detailed information about this.
Yeah, so geothermal development is pretty similar to the traditional petroleum and mining engineer development, that we have to indicate where is our deposit, which is the geothermal field in this in this industry. And we know that similar to the mining industry, that geological exploration, such as drilling and sampling, sometimes really costly, and yeah, it's a huge part of the capital investment. So hopefully, based on our results, the AI modeling and the remote sensing combination, the result will help on the geothermal exploration, that help the geothermal energy become a more popular energy around the world. And thank you.
Yeah, thank you.
Hi everyone, my name is Muhammad Tresnaganda Pradana, and my advisor is Dr. Julian Brun. So my research is about strategic merger and acquisition behavior of coal mining company in various market situations. It means that in the low or high coal price fluctuations and its implication to firm performance. And this is a case study of Firm X, which is a coal mining company from Australia. So the objective of this project is to define if the company can to do merger or acquisition in low price or high price, and evaluate its specific merger and acquisition. The challenge in this project is to study, the study result in a pattern of coal company behavior in doing merger and acquisition, as you can see on the upper right hand of your screen. So this is the operating history, the merger and acquisition of those company, and we can also see how the coal price impacts on their behavior in merger and acquisition. So the methodology I use is the behavior of merger and acquisitions are captured by following their operating history, which is on the right upper hand of the screen. And I also specifically look at one of their largest merger, and I evaluate it using event study, which is the cumulative abnormal return, because we want to look at how the stock price are behave abnormal as they announce their merger to the public. And I also look at their operating performance approach, which is using their resource addition. And additionally, I also look at their financial performance before, after, and after the merger was effectively implemented. Thank you.
Hello everyone, my name is Akash, and my research topic is related to basically study the mechanical behavior and rock support interaction of high porosity limestone using the distinct element method called bonded block models. So this research is funded by Alpha Foundations, and my goal is to basically investigate, interpret the rock failure mechanism, localized damage, fracture growth patterns, and rock support interactions. And using the discrete element method software, and finally develop the pillar strength formula based on the simulated results. So why I'm doing this result, it's basically, when we do underground mining, we need to have a pillar. And like for the design of the pillars, we have a like lot of empirical formula.
Did you get it?
Okay, we have a like lot of empirical. Why my sound is echoing?
I'm trying to mute them. I think, go ahead.
Okay, thank you. Yeah, so we are doing this research because there is like some challenges with the empirical pillar formula like design, because they cannot apply in the post-peak region, or also like they don't have like formulations for rock support interactions. So that's why like we are using a different approach, using two-dimensional bonded block models to study the fracture growth and failure pathway in the intact rock. And this is like one of the preliminary results that I got it. I was able to calibrate my model with the actual lab test that we did on the large scale testing, 0.7 meter and 0.9 meter blocks. And further, like we'll put the rock supports inside the pillars and see how it's going to behave. And we can do for the other rocks also. Like, so next goal is to like do for the coals and generate some, pillar resistance formula. Thank you.
Sorry for that, Akash.
That's fine. And yeah, one more thing quickly. So I presented this research at the SME graduate conference, and I won the 3rd prize at the SME annual conference, this recent conference.
That's awesome. Way to go.
Yeah, thank you.
Hi, everyone. I'm Sarah Jones, and my research is on the value of sustainability. My advisor is Hugh Miller, and my sponsor is the ALA Foundation. The objective of my research is to really evaluate the financial impact of sustainability in terms of what the initiatives that a mining company take and the impact it has on their firm value. The challenge is really how do the companies implement the green technologies? What is their benefit to their firm value in terms of stock price, different accounting metrics, and really being able to quantify what's the impact on the environment and on society. The end goal is really to evaluate which technologies really presented the most impact for the company and the most impact on the environment and society as a whole. The methodology is really going to focus on economic modeling techniques, including like pooled OLS, regression, and synthetic modeling. And the modeling tools will help us compare the technologies and initiatives, the cost and benefit analysis to the firm, and the impact on the environment. So, thank you.
Chaya, whenever you're ready. We can't hear you, Chayo.
Yeah, you are muted.
Okay.
There you go.
Can you hear me now? Okay.
Yep.
Yep. My research is on investigation of factors affecting the lithium recovery on ion exchange process for direct lithium extraction. And the direct lithium extraction is a new method for extracting lithium from brines. It is more environmentally friendly and have a faster recovery compared to the conventional method, like evaporative method. And so what I'm doing here is actually to contribute to the development of this new method by doing a research on the effects of factors that affecting the lithium recovery on ion exchange process for this new method. So the challenge is that despite the advantages, the development of DLE technology still needs many improvements. So that's why I'm trying to contribute to this by doing this research. And the methodology I use a statistical analysis to design the experiment. I created several pH solutions from the initial lithium contained solution. And by that, I can perform the ion exchange experiment on them using the several resins that I try to test. And the result is being assessed by the statistical analysis using a software. I use Statis, and the result could be concluded for this exclusively this resin and this solution for the factors of time, temperature, and resin dose. And that's all. Thank you.
Thanks, Chayo.
Okay, my name is Diane Anderson, and I'm working under Dr. Daglin and Dr. Smith, and I am funded by the SME Stantec and Macintosh PhD Fellowship grant and a Verigold Mining Company, and maybe a third person. We signed the NDA today. My research is taking on the mine planning paradigm itself and seeks to address a problem with pit optimization that has bothered me for nearly 30 years. I complained about this to Kadri when I was an undergraduate student. And it comes down to the three questions that need to be answered for nearly every mine project, except for those when underground and in situ methods are the obvious choice. Question one, how big will the pit be? Two, how much bigger might the pit be in the future? Three, when, if ever, will going underground make more sense? All the technical issues, ESG impacts, and financial expectations for a mine project are linked to the answers to those questions. However, there's an embedded flaw in how we go about answering them. More specifically, the tools we are using possess this deficiency. We rely on 3D models that only quantify the subsurface value to the company and its shareholders. But as my graphic shows here, each grid cell on that surface has value to countless species, to the overall functioning of the watershed, to climate regulation, as well as cultural and spiritual value to the community living in that landscape. These values are currently being ignored by our pit optimization algorithms. Leading practice companies try to integrate these issues later in their project permitting and stakeholder engagement process, but they're generally ignored the pit optimization itself. And these surface values are arguably difficult to quantify, but not impossible. And there are entire other disciplines developing methods that we can draw from. So I'm examining how we can feasibly link the 2D surface optimization methods to what we currently do with the 3D block model, with the ultimate goal being to support this new paradigm that moves beyond the objective function to maximize net present value towards maximizing net shared value that the mine project can bring for species per hectare per generation. Thank you.
Hi, everybody. I'm Sid, and I am characterizing respirable dust for my research. So my world is focused in the industrial hygiene aspect of the mining world. So for my research, I am cutting in the full scale different rock types at EMI, and my project sponsor is NIOSH. I have Jamal Rostami and Jürgen Bruin as my advisors, and I'm also TAing for Jürgen this semester for mine ventilation, because that's in my world here. So for my project, my overall view here is to make the underground workplace safer for people, and characterizing the dust samples to see if dust becomes more dangerous for people with different wears of pick. So the challenges that I'm working with is that I'm dealing with really, really small particles here, particles that are less than 10 micrometers in aerodynamic diameter. So things you can't see on the scale going down to what coronavirus is. So I'm looking at these tiny particles and looking at the shape and the concentration and size distribution of these little tiny particles. So to do that, the methods that I'm using is field emission scanning electron microscope to see these tiny particles with image analysis. And then I'm also using laser diffraction methods and gravimetric analyses to look at all my different particles. Thank you.
Hello everyone, I'm Muthu Vinayak. I'm a I'm doing my PhD in mining under Dr. Jamal Rostami. I work at the Earth Mechanics Institute as a research assistant, and this project, my thesis, which I'm working on, is basically simulating partial phase machines. And before I get into the details, I explain the picture below. The one picture on top is a tunnel boring machine, and if we can look at the number of cutters which are breaking, the fragments happening, all the cutters are continuously engaged, and we call this a full phase machine. And the one below is a mobile miner, and it's like a drum which is cutting, and you can see all the cutters are not continuously engaged, and we call this type of excavators partial phase machines. Just making the nomenclature clear. So what I'm trying to study is the cutting action of partial phase machines using a method called variable penetration, which we developed, which is more closer to the cutting action of partial phase machine compared to what has been done decades for now, has been simulating full phase machines and trying to adjust that to predict the performance of partial phase machines, or develop full comprehensive cut-ahead model based on the simulations of full phase machine. So currently we have the modified testing method, and I'm doing it for all three major type of cutting tools: disc cutters, conical picks, and radial drag bits. And then what I'm comparing is force penetration curve, which is developed using discrete points simulating a full phase machines, versus a continuous stream of cutting as it happens in a partial phase machine for all these type of cutters on different rocks. And all these projects are funded through the research assistant work I do at the Earth Mechanics Institute for various mining companies and equipment manufacturers. Thank you.
I hope you can hear me. My name is Lisa Mayoa. I'm under Dr. Kat Dagdelen, and my research is basically the implementation of a machine learning approach and AI for optimum multi-stage truck dispatch, mixed integer linear and mixed integer non-linear algorithms for multi-goal weight selection in real-time or short-term production planning for surface and underground mining operations. Overall, this whole thing means can you hear me? Hello?
Yes, we can hear you.
All right, I thought there was an echo. All right, so overall, I'm developing an AI. Okay, let me call this one again. I already developed an AI able to adapt to any possible productivity algorithm or productivity formulation, existing or not existing, that modifies and makes this new formulation able to adapt. So this is the key point of this whole research: adapt the whole formulation to any specific possible discrete event in the mine that happens in the real mining scenario, where trucks, shovels, mill operation, production schedule changes over time. And for most, if not all, the existing optimization algorithms, they basically work under a preemptive or non-preemptive logic, where the weights of each goal is fixed over time. What this AI does is basically reformulates every time something happens in the mine, and the goal and the weight of each goal needs to be reformulated. Based on a multi-scenario dataset, considering an existing or not existing formulation in the mine, a predictive model is capable to identify what is the actual global optimal parameters for any possible event, and reformulate the whole problem. And through a sorting and multi-output prediction algorithm, following a feature learning logic that consequently becomes a continuous learning in the AI, it basically aims to always aim for the best possible goal arrangement. So far, this algorithm, this AI, has already been implemented and tested and validated with synthetic data. And the next work to do is to use real data from a mine and validate the algorithm for implementation. Thank you.
Thanks, Lee.
Hello, everyone. I'm Mete, and I'm working with Dr. Düzgün. Started my PhD this year, this semester especially. And my project is on illicit gold and mercury supply chains in Latin America and Africa. Our main countries of focus is actually Peru and Kenya, but the neighboring countries are all in our interest too. This project actually come from a previous project, which was held by again Dr. Düzgün and Nicole Smith, that focuses on only the gold production in artisanal small-scale mining environment in Peru, which was, I think, 4 or 5 weeks ago presented in this mining seminar series by Fatih. Now we are looking for the convergence nodes of these illicit gold and mercury supply chains and the financial chain, which is used to clear the money, this gold, how can I say, the illicit gold and mercury that was involved in the system, and the cleaning part of it. We are very beginning of the project, so I can't give you some results of we obtain, but what we do is mainly using open and some secret data to come up with some patterns and results from that data. Thank you.
Thanks, Mete.
Hello, everyone. My name is Burç Yaman. My advisor is Flue Miller. My thesis topic is mine production planning on the basis of efficiency and quality. And I am willing to start working on my thesis in the fall 2022 semester. I completed my bachelor's degree in 2020, and I started my master's degree in the fall 2021 semester. My sponsor is Ministry of National Education of Turkey, and I am conducting my studies in the name of Etimaden, which is a market leader in the boron production. I completed my internships in open pit boron mine in 2016 and in an underground copper mine in 2018 back in Turkey. So, and my previous experience was in an open pit iron mine in Sivas, Turkey. Thank you.
Thanks.
Hi, everyone. Can you all hear me fine?
Yep, we can hear you.
Cool. So my name is John Poltorek, and my thesis project is on correlating seismicity and geology at AD.
Oh. Sorry about that, John. I accidentally hit your mute button.
Oh, good. My thesis is on correlating seismicity and geology at a deep underground mine. My advisor is Dr. Reddy Kaunda. So the objective of the project, is to develop a system to link seismic activity to different lithologies in the mine. And the belief is that these seismic events that are occurring in the mine are related to rock burst events. And rock burst is a dangerous phenomenon that occurs in underground mines. And the exact causes of it are still not fully understood because there's a lot of factors that go into rock burst causes. So by developing the system to classify the different pathologies by their propensity for rock burst, we can help further the understanding of rock burst in the industry and kind of provide some idea of what might be at-risk areas or what sort of rock properties might be easy gauges for rock burst propensity. And that'll specifically be done using existing brittleness indexes and then stiffness parameters of the rock in their mine. In terms of the methods that I'm using, I am using data from the mine to develop kind of a 3D geologic model, which I've already done, in order to properly identify what rock units the seismic events are taking place in, and then using the material properties from the mine and existing brittleness indices. I'm going to apply the data that they have provided us to those and see that if we can develop any meaningful correlations as to what's going on, and maybe see if that will help them predict where they might have rock burst events. Thank you.
Thank you, John. Amit, did you make it here in time?
Yes, thank you.
Awesome.
Hello, everyone. My name is Amit Moshidlu. I'm a PhD student, and this is my second semester. My advisor is Dr. Rustami, and I'm part of the NIOSH Smart Cities project. In summary, our project is going, goal is to make excavation machines bit smart, evaluate this condition, and work hard and understand the data. The database, so the operators know what is the condition of the bit. Are they in good shape, moderate to burn out, or complete to burn out, and the work that they are doing. And my objectives, my contribution to this project is understanding the rock bit interaction. Also, we'll have a system of rock type and bit condition. My approaches are developing of the data analytics, using artificial intelligence in pattern recognition, and also using machine learning approaches that involve a state-of-the-art deep learning algorithm. We have three different stages. The first part is data collection, like any other project. We have cutting rock tests from NIOSH, and also ongoing projects in my laboratory. And also we have a very unique database, which includes 30 years of database in EMI. And what kind of data that we are looking for? There are forces, drag and normal forces, with geometry and shape, like tip radius, rock like characteristics, like UCS, PTS, and year condition. And I'm going to add some variables to this project and test new algorithm. And at the bottom of right of my presentation file, you can see the potash test and the associated forces, which recorded by our sensors, and it's done by LCM machine in EMI laboratory. And that's all. Thank you.
Thanks, Amit. That brings us to the end of our student presenters. Let me turn my video on. I do want to first say thank you all for participating. I'm not really sure how a question session would go with so many different talks. If anyone wants to stick around, I can create chat rooms for conversations. But before we even move towards closing, I do want to say for any of the newer students in the department, we are looking for new committee members. It is a good way to participate. And please email me if you're interested in doing so. If anyone had any suggestions for doing a question session, please feel free, but otherwise we can end the meeting. Thank you all for bearing with my technical challenges.
We can go slide by slide if people have, and if anyone has questions, they can ask.
That's a good idea, Mutu. Let me reopen the PowerPoint. We do have, we'll keep it to 15 minutes. So, ooh, I'm first again. Let me see. Share screen. Read the comments first. All right, if anyone has questions for me, feel free. Oh, let's go all the way back. If not, I'm definitely going to move on. Does anyone have any questions for Patrick? Also, this is a good time to write down people's emails if you do want to contact them later. So just keep that in mind. All right, stop me if I go too fast.
Hey, Joe, this is Steve Enders. Are you going to be able to post these for us so we can have them to refer to later?
Yes, so I will email the PowerPoint within the department. And then this will also be on our YouTube channel, so they can be referenced there.
Thank you. That's a great idea. I mean, it's really interesting to see the variety of research projects that all the grad students are working on. It's very cool. So thank you guys for setting this up.
I've also really appreciated, I don't know that many of the mining students, so getting to see your work has been very enlightening for me. And also it helps me put names to faces. So thank you all the students who participated. I'm sure you all know people who didn't, so get them to do it next time. Wow, you guys did a really good job. The underminer. All right, so it looks like there's no specific questions right now. Thank you all again for presenting. Also, I hope I wasn't making silly faces because I forgot my video was on. So thank you all, and I'll see you again next week. The following week is spring break.